This is, so was it minus 2 to 2? So minus 2, minus 1, 0, 1, and 2.
Can you see it?
Okay. And then y equals 2 times x minus 3. 2 times minus 2 is minus 4. Minus 3 again is minus 7. 2 times minus 1 is minus 2. Minus 5. Then we have minus 3 for 0. And then we have minus 1. And then 1. Yeah, that seems right. If I was to draw this equation, it would be something like minus 2 to 2. Okay then. Yeah, so I got the if you fill out the table, I got so from going left to right, I got minus 7, and then minus 5 after that. So from minus 5, and then minus 3 if you wrote, and then minus 1, and then 1.
And then how do we draw it?
Let's try it now. So minus 2, minus 7, 1, 2, 3, 4, 5, 7. So we've got minus 7. Okay, 7 minus 1, then 1. 0 to minus 3. 1 to minus 1. And 2 to 1. Okay, so I've got a straight line, and I'll join the dots. Yeah, I got a line.
Okay, and what's its y-intercept?
We've got minus 3.
Yeah, so we know it's correct. Any questions with that?
No, we can continue.
Yeah, that's fine. So I think you're okay for drawing linear graphs. So, and what did you mean by exponential equations?
Or in algebraic division, and I got this far. So what I did was, I had outside a like long division sign. Within that sign, I had x cubed minus 8 plus 8x, 4x plus 12.
Okay, and there's a quick way of doing these using the factor theorem. If you had something, some quadratic, and it was x minus 2 and x plus 3. Actually, I'll say x minus 5. No, 2x minus 1. Oh, that 2x minus 1. So, what are the answers for this one?
X equals 2, or x equals minus 3, or x equals...
Yep. And so to do these, you can just substitute. Basically, what this is saying is when you substitute 2 into the. So if this was a quadratic, if you subbed in 2 for x, you would get 0. And so for this one, if you do the f of 2, you will get 0.
Sure, okay.
So if
the f of 2 should I...
Yeah. So that's a factor, that's a factor. And so this is a solution. Yeah.
So I can just... and we know this is equal to 0. So I've got 2 cubed plus a times 2 squared minus 4 times 2 plus 12 equals 0.
Yeah.
So 8 4a minus 8 plus 12 equals 0. So 4a equals minus 12. Therefore, a must equal minus 3.
Well done. And how could you now fully factorize the polynomial?
X cubed minus minus 3, so plus 3x squared minus 4x plus 12.
Why is it minus minus?
Plus, oh sure, so it'll be minus 3x squared.
Yeah.
And then you divide this you divide this polynomial by x minus 2.
Mm-hmm.
And then so you've got x squared is your first number, and you've got so I've got x squared, and it's going to be x cubed minus 2x squared minus these minus 3 minus 2 is minus x squared.
Yeah.
Then you've got minus x, and then you've got minus x squared plus 2x, and you minus these, and you get minus 6x. Then you have minus 6, then you have minus plus 12. Okay, and then you've got 0. So you've got the thing is x squared minus x minus 6 is the factorized thing.
And so can you factorize that quadratic?
Yes, sure. X minus 2 is one factor. X minus 2, and then so that's the first thing. So you've got x minus 3, and then x plus 2.
Well done. And what type of calculator do you have?
The one that you just the class whiz one.
Okay, so what you can always do is solve the polynomial. Let's just do the cubic one. So if we say it's 1x cubed minus 3 minus 4 and 12, the solutions you get are minus 2. So we know that comes from the bracket x plus 2. We get 3, so we know the bracket is x minus 3. And we get 2, so we know the bracket is x minus 2. So the way we did from the brackets, from the factors to the solutions, you can also go from the solutions back to the factors, if you're ever stuck. Yeah, so I suppose, I mean, because you have the non-calc, no, further maths has non-calc, does it?
It has one non-calculator paper and a calculator paper, yeah.
Okay, so how would you solve this one?
Part 3, so 5 part 3. And this is, so we could use the factor theorem again, so I'll try the f of 1 to see if this gives you 0.
Mm-hmm.
So the f of 1 cubed minus 19 times 1 minus 30. And this is not 0. That's going to be minus 50. So if I try f of I try the f of, it has to be a minus number, I think. So if I try the f of minus 2.
Okay.
So that's minus 2 cubed. Minus 19 times minus 2 minus 30. You get 6 there. So I think I'll try at the f of minus 3. And you get 18 for that. That's not equal to 0. The f of I don't know what to try. I don't know.
So let's see, this is minus 8. That's going to be, I'm putting in minus 2. That's minus 8 again. Plus 22 plus 12. And did you put in 3 and minus 3?
Yeah. Were we doing 3 or were we doing? I know. Okay. I was doing a different.
Go on, what were you doing?
Because I was doing 5 part 3 and you're doing 5 part 1. I thought you meant.
No, if you're doing 5 part 1, that's fine.
Okay.
So you just sub in different values until you find one that works.
So we'll try the f of 3. Which is 3 cubed 2 times 3 squared. And that gives you minus 12. Yep, so minus 3 works for this. The f of minus 3. Therefore, we can say that x plus 3 is a factor.
Okay.
And then we just do algebraic division. X plus 3. Yeah, 2 seconds. So we've got x plus 3 and x cubed minus 2x squared plus 12. You've got x squared, x cubed plus minus these, you get minus 5x squared. So you're going to have minus 5x. Minus 5x squared. Minus 15x. And then you've got so I've got x plus 3 is the first factor, and then got x squared minus 4. X plus 3. And then you factorize this um, x minus you could say x minus 1 and x minus 4, I think.
Okay.
What does it give you? Plus 4, is it? Yeah. Yeah, that works.
Okay. And you have to solve it.
But therefore x equals minus 3, or x equals 1, or x equals 4.
X equals 4. And if you're using your calculator, x equals minus 3, x equals 4, x equals 1. Yep. Any questions there? Yeah, so factor theorem. If x minus 2 is a factor, then x equals 2 is a solution. So you'd sub 2 for x, make it equal to 0 and solve for a. And then you just sub that in. To factorize completely, you try different values to find a solution, work backwards to turn that into a factor, like a bracket. So minus 3 worked, so the factor is x plus 3, and then use long division to fully factorize, to find what the second bracket is, and then fully factorize. Yeah, do you want to practice that more, or you think you're okay?
I do that now.
Okay, so I'm just having some difficulty hearing. It's a bit not the best connection. Hopefully it's alright. This one, I have to flip around. There we go. Okay. Oh, sorry, you just wanted the 7 one.
Yeah.
Okay, how would you find the 100th term?
Yeah.
Okay, so 7 part 1. You just substitute 100 into the place of n. So 2 times 100 plus 5 divided by 4 times 100 minus 1. 205 divided by 399. I get 0.514.
And they gave us they gave it to us as a fraction, so I think we're okay to put it as a fraction. 5 over 399. And that's what you got, was it?
Yeah.
Yeah, so I think it's fine to leave it as a fraction. So I think you're okay for these.
So the limit of the sequence as n tends towards infinity.
Oh, and the limit, yeah.
Yeah. I'll just write what I think, and then can you just check if it's right or not?
Yeah.
So I was thinking it's 2n over 4n, because the plus 5 and minus 1 become like negligible, which is the same as a half. Is that right?
Yeah, and what was our decimal very close to?
Yeah, it was 0.51, so yeah, it's nearly a half.
Yeah, and this would be like 200 over 400, or it would be the same as 2n over 4n. The n's cancel out, 2 over 4 a half. And so, yeah, at the limit reaches as n approaches infinity for the second one.
The second one, we've got 1 minus 6. We've got minus 6n over 2, which is minus 3, I believe. Yeah.
Minus 3. That's it. That's how those work. Yeah, you already know that. Okay, let's say this one. Which question was it here?
We'll start with 2, I think. Yeah, we start with 2.
Okay. So any idea how you begin it? What were you thinking?
The midpoint, so we take the change in, yeah, do that. So, yeah. 4 minus 2 divided by 2 is minus 6 over 2, minus 3. Then we've got 8 minus 1 over 2, which is 4.
And so what was the midpoint for the x's?
For the x's, we're taking 3 away from the x for 2. So we've got, the midpoint is minus 1 for x.
Yeah, okay.
Then for y, it is 3.5.
Yeah. 3.5. And so were you stuck on the second one, was it?
Yes, it was.
So what would those be as fractions? 1 part and 3 parts.
Okay, so I'll just write PR. QR is 1 to 3. So that's going to be 1/4, and then the next. So PR is 1/4, QR is 3/4.
Yeah. So instead of the midpoint, it's the quarter point, if you like.
Sure. So because it's a quarter along, so that means we have so we've got minus 4 minus 2, then divided by 4, giving us so minus 1.5.
So usually the way you'd find the midpoint is you would add the x's and half it. So first x plus second x over 2, and then y1 plus y2 over 2. So that's the midpoint. So you just add them. And so for the quarter point, you would do the same thing except over 4. So you can just add them, 2 plus minus 4, and get a quarter of the answer.
Okay. Oh, that's quite interesting. So then, yeah, minus 4 plus 2 divided by 4 is minus 0.5.
Mm-hmm.
No, yeah, minus 1 plus 8 divided by 4 is 1.5.
Yeah, and you can see that those are both half of the midpoint.
Okay. Yeah.
And then number 3. You could use something similar.
And then, yeah, this is the 7 over 10th point. So you've got, we've got minus 4 plus 2 divided by 10. This is then times by 7, I think.
Yeah.
I've got minus 1.4. Then we've got 1 plus 8 divided by 10 times 7. 4.9.
Yeah, so that's 7/10, and so it's just add the 2 and 7/10 to that. Any questions there?
No.
Okay. And question 3, was it?
Yeah.
Let's see. Yeah. How are you for part A?
A, B, and C, and we want the values of y for which it has a gradient of 2. That means that the change in y over the change in x must give you a value of 2. So change in y over change in x will be the y minus 1 divided by 6 minus 3. And this should equal to 2. So y minus 1 divided by 3 is 2. Y minus 1 equals 6. Y equals 7 in this instance.
Yep. Distance?
Yeah, so the distance AB is 5. That means that if I make a quick sketch. 3, 1. The 6 is constant. Y is okay, so this has to have a length of 5. That means that if we take this as like a squared plus b squared equals c squared, we've got our x value as 3 squared plus, and then open bracket, y minus 1 squared equals 5 squared. And we can rearrange this to get y. So that means y minus 1 equals the square root of 5 squared minus 3 squared. So y minus 1 equals 4, so y must equal 5.
Okay, the whole thing is 5, so y equals 5. Was it C you were unsure about? Play part 3?
Yeah, this was the one that really was tricky.
A, B, and C are collinear. Do you know what collinear means?
And that means they lie on the same line.
Yeah. So how would you go about that?
The gradient must be the same for all points, I think.
Yeah.
Oh, right, so you can say that y minus 1 over 3 must equal to minus 2 minus y over 6.
Yeah.
And you can solve it like that.
Yeah.
I think I can.
Okay.
AB is perpendicular to BC. Okay, I think I can do those two now, the other two as well. Because you can just say, yeah?
Yeah, so what do you know about the gradients if they're perpendicular?
Well, so then one of them's a negative reciprocal of the other one.
And so the way, what what might help to go about solving it, so that's 6 minus 3, is when you multiply them, you get minus 1.
Oh, sure. Okay.
So minus 2 minus y over 12 minus 6. Yeah, and then the last one is just the Pythagoras making those equal.
Okay, that's fine.
Yes, I'll take a look at the next one. Question 4. Yeah. So, how do you sketch the triangle?
So we can. I'll draw the axes first. So one. This is. Two seconds. Wait. So 2 comma 1, 2, and then I just made like some. I used a ruler to get points like that, and then the next one Q, 6, 9. 1, 2, 3, 4, 5.
That's it. And so I just drew in a little scale to help me, but actually this is just a sketch, so you don't need any kind of scale. Just so long as all 3 coordinates are in the top right quadrant and that they kind of make sense, like P is underneath Q, that type of thing. Q is to the right of P and the left of R, that type of thing.
Prove that it's isosceles. Yeah, that's the tricky thing. I don't know how I could do that.
What do you know about an isosceles triangle?
So 2 of the sides are equal in length and also equal in yeah, and the base angles are the same as well.
And so, how could you find the lengths?
Yep. I'll just 2 seconds. I need to. This is isosceles. So then that we have to and prove that the C value for at least 2 of them is the same.
Mm-hmm.
Okay. So we've got the coordinates of P are 2, 1. So I'm just going to find the C value for PQ.
Mm-hmm.
And that, so we've got 2 to 6. That means that the change in X is 4. And we've got 1 to 9 is 8. Length PQ is root of 8 squared. 8 squared plus 4 squared. Root of 8 squared plus 4 squared. And I get 4 root 5.
Okay.
4 root 5 for here. And then we can do QR. Okay. That's going to be. Coordinate R is 10, 2. So then 6 to 10, that's 4. Change in x is 4 again. And the change in y is 2 to 9. That is 7. Yes, 7. So then I think it's QR. It would be minus 7 actually. So QR equals the root of 4 squared plus minus 7 squared. Any number squared is plus, but we can, yeah, it's fine. 4 squared plus 7 squared is root 65. I got.
Okay.
That's. Then the last thing we have to do is PR or RP. The change in x is 8, because we're going from 2 to 10. The change in y is 1. Therefore, PR is the root of 8 squared plus 1 squared, which is root 65. And we can say that because QR equals PR, this is an isosceles triangle.
That's it. And you don't have to also show that the angles are the same. That's implied if those are the same length. Find the area of the triangle. Any idea about
that? We've got the lengths. It's a scaling triangle, so the only thing we could use is half AB sine C.
Yeah.
But we need the angles. I don't know how we could do that.
In this case, do you know how you find an unknown angle involving 3 sides of a scaling triangle?
Are we saying that A over sine A equals B over sine B? Is that the rule?
So that involves 2 sides and 2 angles. Do we have a formula that involves
Sure.
3 sides and 1 angle?
So it's C squared equals not really given the front. C squared equals A squared. Is it minus root of?
I'll just write it out as A squared. And I think they give you this formula, don't they?
Yeah, I think so. In the IGCSE, they definitely give you, but I need to double check that it.
This will come. This is more of an IGCSE thing anyway. Can come up in GCSE though. Yeah. Okay, that's it.
Okay. So A squared. Yeah, we've got our sides. What I might do is just rearrange for cos A.
Okay.
2BC cos A equals B squared plus squared minus squared. Cos A equals B squared plus C squared minus A squared over 2BC. And we can say that A equals the cos to the minus 1 of this answer, which is cos to the minus 1 of, so we need to use that, which is A, B, and C. We can use root 65 and root 65 here. The angle here, we want to find the angle QRP, and that's our A, if you like. So then here's cos to the minus 1 of 4 root 5 so root 65 squared plus 4 root 5 squared minus root 65 squared over 2 times root 65 times 4 root 5. And I've got 56.3 as A. I've got A.
And which angle is that?
That's angle QRP.
So that's 56.3. And when you were substituting in your thing, what was the negative length?
The negative length was minus root 65 squared.
So QR was root 65, wasn't it? And PR was also root 65? Is that right?
Yeah.
So which one was the... So because it's isosceles, they're both going to be the same. So it's one of the angles opposite these sides. That will be 56.3.
Yeah.
So it's...
Oh, right. So
yeah, so it would be either this one or this one. And because it's isosceles, it's both of them.
oh, sure.
Yeah. And so then you would use that to get the area. So it's basically, if we go back to our original equation, this side A is opposite this angle A. And so because you used root 65, the answer 56.3 degrees is the one that's opposite the root 65s.
Okay.
And it'll be the same if you used like little c and capital C. You know, so long as those match up, then everything else works. Yeah, so area.
Okay, so we've got, we need to do 180. Yep, so 180, and then we have to use half AB sine C to get the answer. That's a half of A, which is root 65, times root 65 again, times sine of 67.4.
A half any side times any other side times sine the angle between them. So you could have used this side and this side and the angle between these. So you didn't necessarily need to find the 67.4. But if you're going to use these two, it's because you already knew, I think, what was this one?
4 root 5.
So you could have done a half times 4 root 5 times root 65 times sine 56.3. Because you already had enough there. I'm just going to answer my door once. Hello.
Hi there.
Yeah.
Is it Dara?
It is, yeah.
Hi. This is Corai.
Hey, come in.
Could you mind if I come in for a minute?
Yeah, if you like, yeah. You can just take your shoes off, please.
Yeah, of course.
I'm just finishing up the lesson.
Sorry, we're a couple of minutes early.
Yeah, so 7. You see how it's y equals?
Yes.
So for the other one, instead of y squared, you do 4 minus x squared as like a square bracket.
And then you could get the 2 coordinates there.
Yeah, and then you solve for x, and then you sub that back into this little one to get y. Let's see, this one, the line that meets the circle, calculate the length. So you do similar things here. Oh, puppy, be careful. So you do similar things there. Let's see. Yeah, you can make x the subject if you need to solve. and it's Pythagoras for that one.
Ah.
Seeing.
Okay.
Okay, so some of these, there's a lot. We didn't get to everything anyway. A stationary point. Classify the stationary point. You can find the double derivative, and if it's positive, it's a minimum, and if it's negative, it's a maximum.